keyboard communication with the Nexus board.
Here are some examples of real life. There's a text in an LCD and it scrolls. So our project is just to start. User inputs data from a keyboard and it just comes out on the Nexus LCD. You must be able to manipulate text from the keyboard, just type it in. And it's a 1,000 character array that we're using, but the LCD is like 140 characters, so the user has to be able to scroll back and forth to see what is typed.
So here we have our system block diagram. Pretty simple. We've seen stuff that we've seen in most labs, the LCD, LEDs for testing. The only main thing is that we have the UART, which connects to the keyboard.
And so the software is pretty simple. It's just this is how the data gets from the user to the keyboard to the LCD. And the scrolling function, there's two special keys, the left arrow and the right arrow. So every cycle, it just checks to see if any of these two special keys are pressed. And if it is, then it scrolls back and forth. One of the tricky parts is scrolling back is really simple. Just go back to the array 0. But scrolling forward, because it's not going to, we don't want it to scroll all the way to character number 1,000 when usually that's only until 50 characters. So the tricky part was to find out when the last character was entered and to stop scrolling forward at that character.
So then our overview for the hardware, obviously we used the EDK, the Nexus board, with we used the PS2 connector, especially for the Nexus. We used the GPIOs for the LCDs and LEDs, and we used the standard LCD that we've been using for the whole year.
So pretty much the same thing as previous labs, and these are the two new components, I guess, which is the PS2 adapter and a keyboard. So those are the two new things that are different from previous labs we've done before.
So for the software, we ended up going with a polling. So it'll poll the status register to determine when data was sent to the UART. And so we defined a couple of special keys, or a few special keys. Right arrow key will scroll to the end of the text, or it'll scroll a character at a time until you get to the end of the text, or end of the character array. The left arrow key scrolls to the beginning. Backspace will delete text at the end of the line. We also have caps lock and shift. So caps lock, you just push it and it'll remember and it'll capitalize the letter keys. And that was something that we also had to fix too, based on our implementation. Had to switch, because originally the caps lock was the equivalent of shift, so it would change all the numbers. So like it would change 1 into an exclamation point and such. So that was one thing that we had to fix. Shift, it's like implemented as in video games, like when you enter your name, you push the shift button, you click the shift button on the screen, and then you type the character and it's uppercase. And then all graphic characters are implemented on the LCD.
And Matt did something last minute. Not only did he define special keys, like all the other keys, like F1 or any key which display erroneous characters, he got rid of them. So when you push like F1 or F2, instead of a funny character coming out, nothing comes out. So from doing previous labs, we've come up with like a system of integration and testing, and so we pretty much kept the same thing going on for this lab, which is things like make sure everything is set in the right places, using LEDs to Yeah, like using LEDs and making sure the time for LCDs are correct. That's just stuff from previous labs. Yeah, and writing stuff in small chunks, so you don't just write one big thing and don't know where the bug is.
So for integration and testing specific to this lab, our initial test was to hard code a string, so hard code a test string into in the firmware and have the buttons scroll back and forth on it. And using that, we were able to build upon that. So we also had to use the oscilloscope for the baud rate, and also used it to visualize the keyboard data to see how the data was being sent. So the data line first is pulled low for the start bit, then you have 8 data bits, followed by the odd parity bit, and then the stop bit, which is a 1. So visualize that and kind of see how it's calculated and how it's shown in the UART. Then we used just a lookup table, so each scan code is an index into an array, which gives the character back to print to the LCD. And then also for testing purposes, we had the scan codes written in decimal format to the LCD, so we could see what exactly was going on with our software.
We're at bench 8. Right next to the camera.
Here, I'll do this.
So as you enter keys, just random keys, and then the shift, just push it once, V, and then you get a lowercase v after that, so it resets itself. Caps lock, all capital letters, and then as I was saying, push a 3 and you get a 3 as opposed to the pound sign. Shift key 2, so you get that. And then also backspace deletes the characters. And just push a bunch of random ones. Okay. And then using the arrow keys, you can scroll back and forth. And then it'll scroll back. And then, so it stops right at P, which is the last character I typed. And it doesn't go any further.
Scroll the other way too.
Oh yeah, it'll scroll the other way too.
Nice. Good.
So do you store all the characters in an array and then you
Yeah.
print the
And then
16?
we have pointers for the beginning, so the head of the array, and then the tail of the array. And then as the arrow keys are pressed, it just increments and decrements the array pointers, or indices.
Cool.
Will it override characters if you scroll back and start typing?
No.
Good. Nice.